So in case you needed a reminder, similar figures have the same shape, but they are a different size, and corresponding sides of these shapes are proportional to each other. Take a look at these two triangles, for example. The top one is smaller, the bottom one is larger, but they are similar, so they are the same shape, and thus their sides are proportional. We can highlight the corresponding sides of these triangles to see which ones go together. We can see that the side length 3 on the smaller triangle is proportional to the side length of 6 on the other. And the 5, which is the hypotenuse or side opposite the right angle in our smaller triangle, corresponds to the unknown x side in the larger one. To find the unknown, we can construct a proportion using the lengths of the highlighted sides, but we have to make sure that our numbers are arranged properly. We'll put the short side lengths on the top of our ratios and the long lengths on the bottom. Our first ratio we'll use to describe the small triangle, and the second ratio will describe the large triangle. So we can see in this proportion that 5/6 is equal to 6 over our unknown length x. We can solve that proportion with good old cross multiplication. 6 times 5 is equal to 30, and 3 times x is equal to 3x. If we solve that by dividing both sides by 3, we learn that x equals 10. So our unknown side length of x is 10. If your triangles overlap, then things can get a little tricky. But if you're paying attention, they're no problem at all. Here we see two triangles, one overlapping with the other. We have the large triangle ABC, and we have a smaller triangle ADE. So we can see that the bottom sides, DE and BC, correspond with one another. So side AE is another side that we have to find a corresponding side to on the larger triangle. But because AE is part of a larger line segment AC that makes up the side of that entire triangle, we know that the side length of 6 in the larger triangle is the one that it matches. So now we're ready to set up our proportion. So we'll arrange the proportion so that the lengths of the sides on the right will go on top, and the lengths of the sides on the bottoms of the triangles will go on the bottom. For our first ratio, we'll use the measurements of the big triangle, ABC, and for the second ratio, we'll use ADE, the smaller triangle. So our proportion tells us that 6 over x equals 3 over 4. Now we'll use good old cross multiplication. 3 times x equals 3x. 6 times 4 equals 24. If we divide both sides by 3, we can see that x equals 8. This means that the unknown length of side BC is 8.